Well, good evening, ladies and gentlemen, and welcome to the Walker Institute Annual Lecture for 2012. My name's Nigel Arnell, and I'm the Director of the Walker Institute, and I'm very pleased to see so many here today for this evening's lecture. The Institute was formed in 2006 to draw together the University of Reading's wide expertise in climate change research across a whole range of disciplines. We've got around 150 associates from departments across the campus, but the role of the core team is really twofold. The first is to make the Walker Institute more than the sum of its parts. So in that sense, we're trying to generate new research activity, develop new, innovative, multidisciplinary research projects. The second role is to build links with stakeholders and users of research and try and generate research activity that tackles really useful and important problems in conjunction with those who are interested in knowing the answers and the ways of solving those problems. And a key part of that aspect of our role is the Walker Institute Annual Lecture Series. This is the fourth annual lecture. The first one was in 2009, given by Bob Watson, the chief scientist from DEFRA, on the theme of linking climate science with policy. The second lecture was given by Rowan Douglas from Willis Re on the theme of linking climate science, climate change research with business. The third one last year was given by Rowan Sutton from NCAS Climate on climate science and adaptation. Now, a priority for the Walker Institute this year has been on developing and supporting the research at the university into the links between climate change and development broadly, with a particular focus on Africa. So we're particularly keen or particularly interested to have a lecture this year on the links between climate and development, and particularly on the role of research in supporting development in the context of climate change. I've got one housekeeping task before we move on to the next stage, and that's to ask you all to switch off your mobile phones, because we're being recorded and there's a risk of feedback. So if you all make sure your phones are off. Before I hand over to our Vice-Chancellor, Sir David Bell, who will introduce the speaker.
Good evening, ladies and gentlemen. In my very short time as Vice-Chancellor at the University of Reading, I have come to realise that climate, sustainability, and the environmental sciences are amongst our greatest strengths. And I'm delighted that even recently, a major part of our new investment project in academic posts has these research interests at its heart. But added to that, as Nigel has indicated, there is a strong intellectual commitment to interdisciplinarity, where academics inside the university, beyond, and others with an interest are drawn together to consider and we hope to tackle some of the world's greatest issues. Looking outside is very important for the university. The application and communication of new knowledge should be at the heart of any university's mission and is extremely important to us in the work that we are doing. So tonight's lecture is a characteristic of Reading to engage widely with others, both in the academic community and beyond. The international dimension of the theme of tonight's lecture seems particularly appropriate given Reading's strong and long-standing international links. We have a particular connection with Africa, going all the way back to the original foundation of the University College Reading, where agriculture was one of our first subjects. From our earliest days, we have drawn upon the expertise and the interests of those from across the world. And indeed, if you visit research institutes, universities, and governments across Africa, you will find many a Reading graduate. So that Africa theme is a very neat way for me to introduce our speaker this evening, Professor Chris Whitty. Chris is the Chief Scientific Advisor and Director of Research and Evidence at the Department for International Development. He is also the Professor of International Health at the London School of Hygiene and Tropical Medicine. Chris's experience, interests and expertise are many, but he has a particular interest in researching into the diseases of poverty. He has worked and undertaken research in both African and Asian countries. It's particularly important for government, and I speak with the experience of somebody who's just recently left, that it draws upon highly distinguished researchers and academics. So Chris's appointment to the Department for International Development was the beginning of a drive to utilise even more effectively evidence in assessing and managing issues of international development. I think it is no exaggeration to say that under Chris's leadership, DFID has one of the most highly regarded research capacities and capabilities anywhere in the development community. Overall, Chris is known for his energy, his enthusiasm, and his critical thinking. So, ladies and gentlemen, I invite you to welcome our guest this evening, Professor Chris Whitty.
Thank you. Well, thank you very much indeed for coming to this, and thank you in particular to the organisers for asking me. I say that in a slightly half-hearted way, because when I was asked to give this talk, which is a great honour, I realised I'd be talking to a large number of some of the world's experts in this. The Walker Institute does outstanding research in climate change, and including climate change in Africa. So I'm talking, in the talk I'm going to be giving for the next 45 minutes, I will be cantering through a whole series of areas where I will do in a single slide an entire lifetime of subtle research from at least some member of the audience. And you'll know who they are from the sharp intake of breath as I do it. Before I do that, I would like to, I hope this thank several people who've helped me in preparing this talk, in particular Professor Tim Wheeler, also of the Walker Institute, who is my closest colleague in DFID. Normally he does the climate change work because he's so much more expert than I am in many aspects of it, and working with Tim is a huge privilege. Also Yvan Bio, Alan Tollervey from DFID, and Julia Slingo from the Met Office. And of course many other people, including people whose work I have not plagiarised. I think that's a little bit of an exaggeration. I've tried to acknowledge it as I went through, but who I have highlighted, I would like to put it that way, as I go through this talk. My final caveat has to be that chief scientific advisors have a jester's license in government. They are allowed to say what they think. In fact, they're encouraged to say what they think, which is quite a rare event in public. But it does also mean, the flip side to that, this is a personal view. So don't assume that what I say necessarily represents British government policy. I'm going to take us read through this talk. I'm not going to try and make a big case that climate is changing and that it's caused by humans. I'm going to assume that everyone in this audience simply accepts that. I think the last people who had any doubts about whether it was increasing at the rate people thought about were convinced by the Berkeley study that happened recently. And I think I'm going to assume for this talk we will get to at least 2 degrees above pre-industrial levels and very possibly somewhere in the range 2 to 4 degrees. I think that's what, on the usual basis of government, we should plan for the worst whilst hoping for something slightly better. I'm also actually going to take as read that Africa is the continent which is probably going to suffer most from climate change, rather than trying to lay this out. And the reason I'm not going to try and lay this out in great detail, although I will cover several ways in which it will, is I think it is common sense to anybody who thinks through the problem that this is going to be a substantial problem for this continent. And the biggest reason for this is poverty. Basically, poorer people have very few choices to actually respond to climate change. And therefore, because Africa has one of the largest concentrations of poorer people, and that's projected to continue for some time, it is an inevitability that the impact, all other things being equal, will be greater there. Additionally, there are multiple other factors, and I've just listed a few of them here, which actually make Africa particularly vulnerable. Higher reliance on rain-fed agriculture, which is of a highly seasonal nature. Water scarcity, unhelpful borders from a climate change point of view. One of the things you can do to deal with climate change is move around within countries. In India, it's possible. In many African countries, it's problematic. Cold is seldom a constraint in most of Africa, and the list could go on. I'm going to cover several of the other points. The point is that Africa gets multiple hits when it comes to climate change. So I think I'm hoping that everybody can just accept that this is a particular problem. The starting basis for this talk, therefore, is three things. And the first of which is I do not wish this to sound like we are considering Africa as very much the poor relation, everything is going badly. I have great pride in and admiration for what Africans have done and will do in that continent. And I will talk through some of the changes that have happened, but many of them have been immensely positive. The basis of the talk will be that the main goal of science around climate change, insofar as it's trying to be practical, is to help Africans to solve the problems of Africa. We clearly have a very considerable need to reduce carbon emissions in other countries as part of the overall effort to reduce the impact of global climate change on the whole world, of which Africa is one of the most vulnerable parts. But I don't think we need to look to Africa as a victim to make that point. That point seems to me self-evident. Now, there are a few things that I think it is important to understand when considering climate change as in terms of its impact on development in Africa. And these are issues which I think all lock together to make the issue of climate change in Africa considerably more complex than it sometimes appears from some of the debate, both in the media and, I have to say, also in the academic literature. Because all of these issues complicate the interaction between climate change and development in this continent in particular. The first of which is population. The population of Africa will double by the year 2100. That's a virtual certainty. The exact numbers you can debate about, but that's. And I think the more important point I want to actually point out is in the 1950s, the population of Europe was substantially greater than the population of Africa. By the time we get to the end of the century, over a third of humanity will live in Africa, and the population of Europe will be relatively unimportant. This has two obvious implications. The first of them is that scarcities, of which climate change is going to cause many, will have a much bigger impact because you're having to deal simultaneously with a reduction in supply, potentially because of this, and a huge increase in demand just on the numbers. The second of which is people often say it doesn't matter thinking about low-carbon growth in Africa. Well, it certainly does. If you think about this, if you think about a third of the world's population, the path that Africa takes in terms of its development and how it uses carbon is going to have a huge impact on the rest of the world. The second, which goes with this, is that each of these people will consume more. And there are at least two reasons for that. Changing habits, greater wealth, which is a very good thing, but that will lead to greater consumption, and also the simple fact of the population pyramid. The population pyramid in most African countries at the moment has the largest group is young children. By the time we get halfway through the century, the majority of people will be adults, and that has their consumption will in multiple ways increase. The next big trend is economic growth. And this, I think, is often very under-considered when people think about the implications in Africa. Clearly, if Africa is increasing in its development, that will have implications in its carbon use. But I think the more important thing is that it will have substantial implications for the ability of African nations and African individuals to respond to the challenges that climate change has. And one of the things that always surprises me is that otherwise intelligent people do modelling on climate change which seems to assume that Africa in 2050 will actually be the same Africa we have today. That is absolutely untrue. The great majority of African countries are now accelerating in terms of their economic growth at a rate which we can only look at with admiration. Even Zimbabwe, bottom of the list, has a rate of growth that the Chancellor would die for. And this is being compounded year on year. And alongside this, many things are happening. For example, there was something, those of you who read The Economist will have seen that in Africa, over the last 10 to 15 years, the mortality rate in infants and children has dropped by 40% throughout the continent. And that is accelerating. So the Africa that is going to face the big effects of climate change will be a totally different Africa from the Africa we have now. The next big change is urbanisation. At the moment, the majority of Africans are rural. By the time climate change has its greatest effects, the majority of Africans will be urban. And the challenges they will face, these are both photos from Lagos, will depend on whether in this part of the urban spectrum or this part. But urbanisation has very considerable implications for climate change impact for obvious reasons. And clearly, because of limited resources, which are happening in a number of different areas, we are likely to see price volatilities. I've illustrated this in this case by the big volatility in price of agricultural goods, but I could have mirrored this in a number of other products, where the volatility is increasing as demands increase and supply does not increase so quickly. And the reason volatility is problematic is the poorer you are, the bigger the impact that volatility will have. So these issues have to be viewed in combination when we think of the impacts of climate change on Africa. Some of them will work against Africa, and some of them, particularly economic development, will work for Africa. But whatever we're dealing with, imagining that Africa will be the same in 40 years as now is clearly unhelpful from a policy point of view. Now, moving on specifically to climate change, clearly all of you in this room will know the headlines. I'm just going to make a few points on this. The first of which is that, unfortunately, in terms of prediction, the things that are easiest to predict are often the least important from a development point of view. CO2, mean temperature, these things are relatively predictable using current models, and yet their impact actually is of pretty trivial significance viewed against a number of other issues. The kinds of things which actually are going to have big impacts, changes in rainfall patterns, flooding, and variety, which we'll go through, are actually much more difficult to predict. But I think what we can say in general terms is that in overall, the impact of virtually all the climate change effects will be negative for Africa as a continent. But there will definitely be some winners as well as losers. There will be some parts of Africa that will actually look in better shape if climate change goes the way we think it's going to than they do at the moment. But overall, the effect will definitely be negative. Making an obvious point, clearly, when we're thinking about climate and weather, there is a very large spectrum in terms of the predictions we can do, ranging from the short-term, very short-term weather forecasts through more medium-term, seasonal and then decadal forecasting, and on to the effect of climate change. In very broad terms, and for multiple reasons, the further out you go in time, the more difficult these are to predict. Clearly, the challenges in Africa are different from the challenges of prediction in Europe, but this forecast lead time does actually lead to implications. And what you need in terms, if you're a farmer, you're broadly interested in the early seasonal, up to seasonal things, if you're a farmer now. If you're a planner thinking about where you should put major infrastructure projects, then some of the the larger decadal and climate change impacts are more important. But your confidence boundaries are increasing. And this Met Office slide, which they kindly gave me, I think clearly does not do justice to the degree of uncertainty we have as the fan actually looks a much wider thing than that. This is just schematic. That doesn't mean, however, we can't actually improve the modelling we can do, and every improvement we do will help both in the immediate term and in the longer term. I'm just, this rather nice slide, again from the Met Office, shows that as we've increased both our ground observations and our modelling capacity, our ability to predict, for example, a very important thing for farming, the onset of the West African monsoon. For those of you who've actually been in West Africa, be aware of the fact that for much of Africa, much of northern Nigeria, for example, for 9 months of the year, there is no rain at all. But there is a lot of rain in a short period of time. Being able to predict that has substantial implications. These kinds of things are improving and will continue to improve as our models get better. There's a legitimate debate about whether our improvements in short-term weather forecasting actually assist our long-term capacity to predict climate change, and there are different camps, and I'm certainly not competent to referee between them. But certainly in the short term, our modelling is improving the whole time. However, there is a considerable difference in the importance of different sources of uncertainty over time periods. So the model uncertainty I'm talking about, reducing that has a significant impact in the medium-term output. And I'm plagiarising completely here from a Hawkins and Sutton paper, which Tim has brought to my attention. On the other hand, the scenario uncertainty, things like what will actually happen to our emissions over time, these have a greater importance as we go out in time. And the internal variability, things like El Niño effects, these effects tend to decrease as we go out in time. But overlaid on top of these, from a policy point of view, is the greatest uncertainty of all. And that is, what will Africa be like here compared to Africa here. I'm able to predict to a certain degree where Africa will be in 10 years, although it's changing at such a speed, even that is a stretch. I find it very difficult to predict where Africa will be in 40 years' time. And that will actually have a much bigger impact on what will happen in terms of African climate change than many of the modelling improvements that we're talking about at the moment. Now, just thinking about some of the kinds of complexities from a policy point of view, let's just consider, for example, water. You could consider water in terms of rainfall. This map here is a rainfall in terms of millimetres per annum. Rainfall patterns, total amounts of rainfall, duration of rainfall, dates of onset and finishing of rainfall, very important in the short term in terms of rain-fed agriculture. If, on the other hand, I'm very interested in looking at the impact of climate change on Africa's ability to produce hydroelectric power, I'm much more interested in the effects on the river systems, which are a different set of challenges. Here is one of the modelling attempts to try and see what changes in precipitation would lead to in terms of changes in runoff and, in due course, in river outputs. So the impact, even if we just took water systems in a very narrow sense, there is a lot of complexity to the systems we're talking about. And I'm highlighting this only because they're very beautiful maps and they came out very recently and they were funded by DFID. This very nice sort of synthetic approach, which the British Geographical Survey did, got a lot of news time, to their surprise as well as ours, which looked at the aquifers in Africa, demonstrates that here's another level of complexity. Now, aquifers probably are not going to be terribly major importance because they're either in the wrong place or they're too deep, at least if we're talking about the immediate terms. They might, for example, have implications if we were thinking about how can we store energy from solar power. There are a number of ways we might in future need these kinds of bits of information. But again, the actual, just the distribution of water in Africa is a complex issue, leaving all other things aside. Moving on to crops, which is one of the things people tend to talk about in a slightly, I have to say, slightly hand-wavy way often. There are multiple approaches to modelling what the impact of climate change will be. And this, again, is as it happens, DFID-funded a systematic review done primarily by colleagues from Cranfield University. And this is a summary of all the studies that have been done to date with reasonable quality. And the first point to say is that there will be a significant reduction from climate change if you keep all other things being equal, and that's a very big caveat, from climate change in many of the key staples that are used at the moment in the African diet, the exception being rice. And I think if you look across, I think that makes credible sense for a whole variety of reasons, although there are factors, some of which make things worse, like temperature, some of which, like CO2, may even make things better, and rainfall as well. But around those, there is huge distribution. So these models are actually based on a very wide distribution of actual models themselves, and in reality, we cannot say for certain what is going to happen, even if we aggregate across the continent as a whole. And clearly, within the continent, there will be very substantial variations. And this is just one of the examples of people trying to model out the effect of agriculture on different parts of the continent, some of which will see an increase in their agricultural productivity, potentially, if the models are right, if all other things are equal, if a whole variety of other things. And that's very important, lots of ifs, and some of which will clearly see a decrease. So the losers will outweigh the winners. That's not to say that, but science has a lot more to offer than simply prediction, although prediction is an important part of it. One of the key responses to this is to accept that across Africa there will definitely be places that will become drier, will become wetter, will become more saline intensive for a variety of reasons, and we can actually respond to that with a different form of agriculture, another area that Reading University has great expertise in. Highlighting, again, 2 or 3 things. Scuba rice, something for which DFID actually got a prize last year. It's very nice. So Tim picked it up. And this is a rather nice illustration, not actually deliberately designed for the African market, but this is something which is able to tolerate both flood and drought in a way that previous varieties have not. Or the new rices for Africa, the Nericas, which are substantially more likely to be much more productive and also more able to tolerate a more narrow range of situations than traditional African rice varieties. So the whole time, whilst climate change is going on, we are improving our ability to produce various crops and also livestock responses which are able to deal with some of these climate change things. I'm not saying they wipe it out, they definitely do not. And the reason for doing this is not primarily climate change, the reason for doing it is the natural variability in weather that farmers already have to face. But the reality is that the technology behind agriculture is changing at the same time as the climate change is changing. Putting those two together, again, even all other things being equal, is quite complicated in terms of predicting where we will be. So where will we be by 2050? Well, I mean, here are a few of the kinds of things we don't know. Where will we be in the spectrum between this traditional pastoralist things, which is actually a very good adaptive mechanism, and this, which is Brazilian agriculture at its finest? We'll be somewhere, and it may well be both, I think, is the reality. The yield gap, we are going to have reductions in agriculture because of climate change, but there's a huge yield gap in agriculture, meaning the difference between what agriculture in Africa could produce now and what it does. Probably you can make up 40% of that with existing technologies. Nothing new, just nitrogen. So nitrogen, most soils in Africa are nitrogen poor, better use of hybrid seeds that already exist, better use of different forms of producing water in situations. We talk a lot about the staples, the maizes, the sorghums and so on. It's likely as people get richer that these will become much less important in people's diets. So actually be much less reliance on single crops. Pastoralism, what will happen to that? And particularly what will happen to that in a place where the dry, the semi-arid areas where pastoralism tends to be, move around in a way that doesn't suit boundaries. May there be a switch to meat, and so on. I could go on. The reality, though, is the agriculture we're talking about, and this is my recurring motif, will be very different in 2050 than the agriculture we face now. Moving on to health, my own area of trade, I have seen, there is no doubt that the impacts of climate change on health in Africa are going to be bad. Let me start off a section which is going to be a bit more subtle than that now, but I don't want anyone to be in any doubt that that is my belief and that is what the evidence shows. However, there is a lot of rubbish written about this, which actually hypes up a lot of things in Africa, which make an assumption that Africa is somehow going to stay exactly where it was in 2000. This is a pretty typical thing from a newspaper front page from the States. It shows one of those beautiful kind of map things showing the contribution of Africa to global warming. Here, this is a very standard one, and how big the impact of climate change will be on health in Africa compared to other continents. These numbers are totally bogus. Many of the problems of Africa that Africa faces, I can see no realistic link to climate change at all, other than an extraordinarily strained logic going through about multiple steps. HIV, for example. I could, I suppose, argue that it's so hot that people have to stay indoors and they have more HIV. Pregnancy, deaths in pregnancy and neonatal deaths, two of the biggest challenges of Africa. I cannot see climate change having any serious impact on this. So some of these you can just wipe out just with common sense. You don't need really any science. There are also, now the area where it would look as if there should be a very clear impact of climate change directly, and I'm going to come on to the indirect effects, are the classical tropical diseases. And I'm going to use an old-fashioned notation, which is now not terribly widely favoured in the public health area, but I'm going to use it because I think it helps to understand this, which can be based around the waterborne diseases. That's ones you get from actually drinking water. The classic one's cholera. Water-wash diseases, ones that you actually get from not having enough water to wash your hands after you or the person who's preparing your food has defecated. Don't think about it too much before our drinks thing. Water-based diseases like schistosomiasis, which actually you have to bathe in the water or have some contact with the water, and water-associated diseases, which are where the vectors, like dengue or malaria, have to live in a particular water environment. And these ones are the ones that people tend to talk a lot about in terms of climate change. Now, quite a lot of these, in theory, if all other things were equal, climate change would have a big impact. For example, this one here, guinea worm, is based really around people all bathing and drinking from the same pools of water. And with climate change, the number of these will decrease. The concentration of people drinking from them will decrease. You could argue that guinea worm should increase because of climate change. I think I can make it's a logical argument, except we will probably eradicate guinea worm sometime in the next 3 years. certainly well before climate change happens. And for very many of the diseases that actually logically climate change, if you just had an experiment in which nothing else in Africa changed apart from climate change, they would have an impact on this, but actually many of these diseases are decreasing. Or there is a realistic probability that by the time climate change happens, they will no longer be as important as they are. Take dengue, for example. Dengue is a vector-borne disease, probably will increase with climate change, but it is highly likely there will be an effective vaccine sometime in the next 20 years, very possibly earlier, in which case this ceases to be the problem that people are predicting. I'm going to illustrate this with malaria for two reasons, partly because it's a disease that people talk about a lot, and secondly because it's a disease I know a fair amount about. Now, there's no doubt at all that precipitation is what is the biggest driver of malaria in Africa. And I'm illustrating this with Nigeria. In Nigeria, in the southern part, where there's basically humid climate all the way year-round and precipitation is less seasonal, you get year-round transmission of malaria. The further north you move, the more seasonal it is, therefore, i.e. the more rain there is, but at very concentrated periods, the more this only happens in a few months of the year. Malaria is driven by rainfall patterns, and we know that, as a minimum, climate change is going to move rainfall patterns around. It may or may not increase the mean things, but it is likely to move them around. Therefore, the probability is, as a minimum, climate change will move the capability to have malaria to different parts of Africa than it is at the moment. However, there are lots of models which actually predict what the effect of climate change on malaria will be, and the bottom line of all of them is it's bad. Life's getting worse. We're going to have invasions of malaria all over the place. I've just illustrated one of them. All of Europe turns red. Lots of malaria in that kind of area. Increase in malaria in many parts of Africa. I've just quoted this. This is a Bloomberg, very responsible journal, report carried on the UNDP website, and they say that global warming will put millions more people at risk of malaria, according to the report. The UN chooses to put this on their website, so they presumably think it's a fair reflection of what they actually said. This is actually malaria as it was 100 years ago. And as you can see, malaria used to be a problem in all the places that are meant to be getting malaria fairly soon, but they've been got rid of because of development. And actually, over the last 5 to 7 years, there has been a reduction in incidence of malaria of 23% and a reduction in mortality by 33% at a time when the climate models would predict that there will be a slight increase in malaria. Now, there's nothing wrong with the models, they're right. But what's happened is that much better control of malaria and development have meant that actually it's irrelevant. The contribution of climate change is so small compared to if they increase malaria by, let's say, a third, and we can reduce the incidence of malaria using existing tools by, let's say, 70%, it's clear who's going to win. And it's going to be the development. The reason I'm stressing this point is it is really important when we're thinking of the policy implications of malaria, of climate change, not constantly to be going back to the world as it is at the moment. We have to be thinking about where will the world be at the point when this is going to have an effect. The area of direct impact where we think that the climate change almost certainly will have an impact potentially is the water wash diseases, which are where there's not enough water and there's poor sanitation. Some of these are likely to be improved just by development. Some of them are likely to be improved, like trachoma, by good control mechanisms, but there may well be a direct remaining effect where climate change does have an impact on the poorest, on increasing their risk of these serious water wash diseases. And this may well vary between urban and rural settings. So this is just one of the UNICEF predictions of where we are now in terms of urban versus rural access to drinking water, that means safe water. In broad terms, rural areas have a much wider range of water-associated diseases than urban ones. But therefore, as the continent urbanizes, actually the problem is going to reduce, again, all other things being equal. These two effects will push in different directions. Now, it's not to say we can't get water. There've always been, since the Romans, there've always been engineering solutions if you've got enough money. The problem has always been, in the Roman times and now, that the poorest, whether it's the poorest nations or the poorest individuals, cannot afford to pay. There is, however, a way in which climate change clearly is going to have an impact on health, and that is by the indirect but extremely important driver of socioeconomic development. The impact of climate change is going to, overall across the continent, going to be wholly negative. And this is these are hard figures. This is one of Hans Rosling's slides, but it's very good in my view. This is GDP per person in US dollars, and this is life expectancy at birth. And this is every country in the world plotted on this axis, and it's a logarithmic scale for those of you who like the maths. And the astonishing thing is the complete liner. If we have poorer countries as a result of climate change, we will have less good health. It follows as night follows day. So the big impact of climate change on health will be the impact it has on socioeconomic development in these countries. Moving on to humanitarian issues. Sorry, just going back to this one. One point just to point out, for those who feel always very gloomy, the worst health things in the world are Zimbabwe, Afghanistan, and arguably Lesotho. That's just because of HIV. 150 years ago, the UK was the richest country in the world, and it had a worse life expectancy than the worst country in the world does today. Things are genuinely improving in every continent, including Africa. Turning to humanitarian crises, several of these people talk about a lot in terms of climate change. The first one is earthquakes, tsunamis, and the dramatics. I mean, I think everyone remembers the tsunami. The impact of climate change, really, on these is probably relatively marginal in Africa. And the big impact it's likely to have is spreading the concentration of people in places which are vulnerable to sea problems at the same time as the sea will actually slightly increase. That is likely to be the big impact. But actually, this, for fairly obvious reasons, when you look at a map of seismological activity, is less of a problem when you're thinking about Africa than it is in Asia. This is a problem, but it's unlikely to be a particularly big deal in an African setting. I'm not doing well in my college's thing. When it comes to floods, this is a slightly more controversial area. There's no doubt that climate change will be a significant cofactor in the impact of floods. The impact of floods in terms of the climate change increasing the frequency, I think there's a general feeling that the evidence would generally support the idea that there will be more flooding, again, all other things being equal, and that will compound the fact of change in land use, population density, and people moving into what would now be considered marginal land. So these things will come together in a very bad way. And climate change, as a minimum, won't help and will probably increase, as I say, the frequency overall. And if you look at the recent migration report done by Foresight, which is an extremely interesting piece of work for multiple reasons, if you look at the population of Africa, Africa being the purple and browny ones here, that actually is living in floodplains and low-lying coastal areas, that will substantially increase, meaning that any effects of climate change, in this case, the development impact will go the wrong way. Any effect of climate change will actually be worse as a result of this degree of development. When it comes to drought and famine, the IPCC's prediction is the frequency of failed rains may well increase. Of course, that doesn't necessarily translate into famine. There's always an assumption that drought equals famine, and that is true for very poor people in poor areas. But famine is a socioeconomic factor, function as much as it is a rainfall one. And these factors are much more likely to determine whether famines occur, although there's no doubt that climate change is unlikely to help. It is also, however, likely to change the geography. So, for example, the Horn of Africa, which most people in the UK would associate with drought, including now, and therefore famine, is in fact, if anything, likely to be one of the areas which may well get better from a drought point of view. This is the most recent IPCC special report looking, and this is just one of the measures of dryness, changes in consecutive dry days. But as you can see, this is quite maldistributed across the continent, with particular problems concentrated in southern Africa. But here's the Horn of Africa, much less of a negative impact. And in diseases, one of the things that is likely to happen with climate change is that diseases will move around. And the reason that's important is that diseases that are actually fine in certain areas because of either genetic stock or because of immunity may well move as a result of climate change into areas where that is not the case. So I've illustrated this because I like the photo of blue tongue, which is an African problem we now have in the UK, probably not due to climate change, but that is a very typical example of the kind of thing which is likely to happen over time as climate change bites. And finally, on humanitarian, the very controversial area about whether climate change is likely to lead to increased political disturbance. There are at least as many opinions on this as there are people writing on it. The reality is that the logic of it is sort of, at a facile level, extremely compelling. The evidence that actually this happens is extremely weak. The case that a lot of people quote is Darfur, and people say, well, maybe it's because of weather changes, not climate change so much, that actually there was a conflict between the nomadic Arab groups who were pastoralists primarily and settled African farmers. Actually, the evidence for that, when you look at it closely, is pretty feeble. And I'm afraid there is an awful lot of pretty unimpressive socioeconomic, socio-political analysis on climate change, which this kind of thing, which isn't actually about climate change, is pretty typical. Drawing a parallel between Rwanda and Darfur, which are clearly totally different problems with different drivers and different outcomes, these kinds of unhelpful parallel probably lead to unhelpful parallel. Low-carbon pathways. For reasons that I pointed out at the beginning, low-carbon growth for Africa is not only good for Africa in the short term, but if a third of the world's population are going to be Africans within less than 100 years, it's jolly important for the rest of the world in the medium to long term. The problem we have is that African countries are constantly urged by people like me, coming from the north, that they must follow a low-carbon growth, and it's a win-win all round, we say. It's a win-win all round. We're very, very enthusiastic about that. African ministers privately say low-carbon growth equals slower growth. And the problem is they're right. At the current point in technology, it is cheaper to get energy from carbon things than all the other methods. That's the reason we're using carbon. If it wasn't for that, we'd move over very, very quickly. And because these are very resource-constrained countries, if they're going for the more expensive option, they are clearly going for an option which is less good for them. And to compound this factor, a lot of the technologies we actually privilege because they're good for us, because they suit our environment, are unintentionally pro-north. I come, although you may not know it from my accent, from the northwest of Scotland. This is a fantastic, wave power is a fantastic invention. If you're in the Isle of Skye, it's rather less useful if you're in Chad. Moving on to some of the different methods that people could well be pro-south. Here are some of my own reflections on this, but this is a difficult area in which there are many competing points. The first one is solar. Africa, pretty obviously, is not short of sun or land. Obviously, equally, not all sites are appropriate for solar. You also need things, for example, to keep the solar panels clean, and that includes water. India, for example, is finding difficulty in some of their solar areas because of a shortage of water, not because of a shortage of sun. Dust storms and so on can cause problems. But there's no doubt that there is a lot of sun there, and if you look at the technical assessments, more energy, in theory, could be generated from the sun in Africa than all the world's energy needs at this point in time. So, in theory, this is a good win. There's no doubt that in terms of small-scale development, off-grid power, getting to people who currently have no power at all, solar is a fantastic win. And I think over the next decade, it'll be transformational in terms of development lives. But the impact of this actually in terms of reducing carbon will be minimal. This is very pro-development, but it's not really part of the climate change debate, except at the margins. For the big developments, there'll have to be significant progress in technology. And the big ones are probably actually transmission and storage, particularly if you're trying to actually get all your energy here. That's not where people live. And many of the recent technological advances are great. For example, there's now very good data, experimental data, suggesting that there are certain situations in which if you cool below 32 degrees and ideally substantially below that, transmission, you can get much less fall off in transmission over time. Well, that's great if you're in Germany. It's not terribly useful if you're on the Sahara. So I think we need to, this technology is advancing the whole time, and we may well have transformational technology. More likely we'll have incremental improvements in technology, which in due course means this technology will become possible, but it's not currently. Hydro. Africa has several river systems which are producing significant hydroelectric power, although climate change will not help all of these, particularly the ones in southern Africa. There's likely to be a negative impact from climate change. But of course, set against that, the ecological and health impacts of these are often quite substantial. Anyone who reads the newspapers is aware of that. I've just illustrated that with the Aswan Dam, one which actually has as many detractors as it has people who are enthusiastic about it, and it causes enormous debate in the development communities whether it's a good thing. And when the dam's upstream, let's say Ethiopia, and you've got the river downstream, let's say Egypt, this is a recipe for potential conflict in a way which I think some of the other conflicts people talk about are less realistic. So I think these challenges are non-trivial. Then biofuels. Certainly for transport, the other problems are, individual transport are not always going to be, or at least at this point, going to be problematic. Biofuels sounds great. And there's always, the vogue for biofuels is comes and goes over time. At the moment, it's in a bit of a go. And that's because there was a reasonable evidence that the use of biofuels, which led to some part of the spike in food prices that was so problematic for poor people. Now, actually, a lot of the reason for that is the biofuels are being produced in countries where they simply are not sensible, i.e. the north. It does not make, there's a superb book, which if you haven't read, I really strongly recommend, done by my opposite number in DEC, David McKay, called Renewable Energy Without the Hot Air, that demonstrates that basically biofuels, if you're talking about Germany or the UK or America, just make no physical sense. You just would have to give almost all of Wales to sort of drive 2 miles. I can't remember the exact figures, it's not quite as bad as that, but there's a very, very substantial. But once you get into places where there's a lot of sun, then the biofuels become a considerably more realistic proposition. But this is a very considerable concern. The ideal would clearly be to have biofuels that can be grown on agriculturally marginal land, where they're not competing with foodstuffs. Now, for a variety of reasons, that actually sounds implausible, but it is not actually biologically impossible. And I've taken as an example the big sisal plantations there used to be in parts of East Africa. I've taken this from Tanzania. Now, there are a number of reasons this is not a very good development slide, starting with the child labour. But the fact is that there was a thriving industry, and now it looks like, which looked like this, and now it looks like this. And that's because this is agriculturally marginal land. But if you could get things like this again, there is actually, you might be able to square this particular circle. It's not, of course, that we don't have things that can be turned into biofuels. There are some countries that are already using ethanol, particularly from sugarcane, to trofa. There are a variety of other methods. But there is a problem with all of them, that they are, in general, competing with foodstuffs, and the implications for the poorest is likely to be quite a double-edged sword. And finally, I've talked a lot about the more physical and biological sciences, but the behavioural sciences are going to be absolutely essential on this. The way in which communities adapt to the changes that climate change are going to bring are going to be very heavily determined by social, political and economic factors. And understanding those will be at least as important as understanding the modelling of the climate and that side of things. The problem about that is it's difficult for the social sciences to happen until you know where the changes will happen. And at this point, we really don't. But the fact that the social sciences are central, I think, can't be underestimated. So, summarising some of the points I've made. Predicting the future, we can certainly, using modelling methods, improve substantially our ability to predict the impact of climate change in terms of the impact on climate itself, but translating that into the impact on agriculture, on health and so on, is very, very difficult because there are so many moving parts. And I think many of the attempts made to do it actually are unhelpful from a policy point of view because they give a false sense of certainty when actually, if you're honest about the error bars, they'd be so big, they'd be largely meaningless. So improving our modelling, absolutely essential, but don't go beyond what the evidence currently allows us to do. That would be my plea, I think. The second thing is that increasing our range of options as to how we respond, improving our plants so that they're tolerant of drought and flood and salt, improving looking at the diseases that may get worse, like dengue, and actually producing countermeasures. The more tools we have in the box, the more we'll be able to respond. Saying we will use this here and we will use that there is not possible at the moment, but policymakers in the future will thank us if we can hand them a very large toolbox from which they can select the things that work for the combination that they work. So that area of science is going to be critical. Thirdly, improving resilience is the key to responding to climate change, but it's also the key to helping the poorest people actually get through their problems at the moment. Things that actually will help them with climate change in terms of ability to deal with droughts, ability to deal with floods in low-lying areas, are just as important now as they will be in the future. So, in a sense, anything we can do which will help resilience will help poor people now, very pro-development, and help us deal with climate change in the future. This is absolutely essential. My final point is really a very positive one. I think people, when they look at Africa, very often feel, well, what's the point? There's no ability in Africa to absorb these messages or to act on them. All I can say is that is based on total ignorance about how things have been going in Africa. I would say Africa has more than its fair share of outstanding political leaders and highly technical political and official leaders in government. It is far more likely that if you talk to a Minister of Agriculture in Africa or a Minister of Roads in Africa, agriculture you'll talk to a farmer, Minister of Roads in Africa you'll talk to an engineer, and Minister of Health in Africa you'll talk to a world-class research physician. I've chosen Dr. Tedros, and none of you will know him, Minister of Health in Ethiopia. I've just chosen him as an example, or Awa Kolsek, who used to be Minister of Health. These are serious academic players than you would in the UK. There are outstanding ministers in the UK. My Minister, Secretary of State is a great leader in international development, as are the other ministers, but none of them are claimed to be scientists. Whereas actually, when we talk to our counterparts in an African setting, that is what we tend to be dealing with. So I think the idea that there is either lack of political leadership or lack of technical skill in Africa is a misrepresentation. So I want to leave on that positive note because I do think that although climate change is a big challenge for Africa, I think there are many things we can do to help deal with it. And I do think Africans themselves, if we give them the tools, when I say we, I don't mean we here, but we, the community, our generation, give them the tools, I think Africa itself will be able to use those tools to deal with many of the big challenges that Africa is going to raise. Thank you very much.
Right, well, thank you very much, Chris, for a stimulating and thought-provoking talk, and you're happy to answer some questions now. So we have a question and answer session. We've got some roving mics, so please wait for a microphone before you ask the question, and can you give your name before you do ask the question? So first question, please.
I'm Stephen Belcher. I'm head of the Met Office Hadley Centre and also a member of the University of Reading. You developed the theme, so I'm going to ask you what forecasts you think Africa will require, but let me give you some build-up. You developed the theme of that resilience is what's required in order to give you adaptive capacity for climate change, and that will build as the continent gets richer. So given that, understanding the extremes and how extremes will change in Africa seems to be a natural corollary of that. So would you agree? And if so, what forecasts would you like with better skill? Just one category, please.
Well, on the first one, that's what my lawyer friends would call a leading question. The answer is yes. Clearly, you can't go wrong having greater capacity to forecast it. I think it would actually depend on where we are in terms of the timescale. So if you can tell me when you want it, if it's now, it's going to be seasonal forecasting. That would be the ideal. But once we get out to a situation where probably much less of the food needs of Africa are met by rain-fed agriculture dependent on areas where it's highly seasonal, I think other things are likely, like extreme events, are actually likely to be much more important. So I think it depends where you pin the tail on the donkey. So I've given you two answers, sorry. But,
Hi, I'm Kerry Tawney from DFID. My question is about the use of models. I think we have some very extensive and robust climate change models available. What about the economic models? Do you think they're good enough? And do you think we should be doing more work on those? Clearly, if we have a problem with growth in the next 50 years, the impacts of that could be much more extensive than that of climate change.
Well, I think that the short answer has got to be no. In terms of the economic models, I think the economic models are very useful in trying to help us. For those of you, sorry, I'm going to give a techie answer to this one, so apologies for those who want. The key to the models at the moment, I think, is their sensitivity analysis. That they actually help tell us which bits of the system are likely to have the biggest impact on economic things. But as predictive tools, the economic models, even in the short term, are not terribly good. And by the time you put in the large number of imponderables, of which I've only talked about a few today, even the best model is going to fall down. Because the thing about models is they both combine the need to have got the information right in the first place, and the further out you project, the more iterations you get, and basically the more unstable the model is mathematically, so the greater the variance you're going to get around that. So my view is there's no way we can rely on our current economic models to help tell us what to do in Africa in the future. But they do help us make more limited decisions about what do we need to know and what are the particular drivers we'd like to face.
Ryan Sutton, University of Reading. I just wanted to pick up on one thing you said, and I was slightly surprised you said it, and I wonder whether you really meant to say it.
Usually that means no.
You used the phrase well before climate change happens. implying that this is a somewhat far off concern for the future. Clearly, the reality is that climate has already changed and continues to change. It's changed significantly globally and indeed in Africa. And I think it's a very important point to appreciate. And of course, the extent to which it's changed in Africa as a consequence of human activities is a very active field of research. I mean, the prolonged Sahel drought, for example, is still widely debated to what extent that was a consequence of human activities versus a natural phenomenon. So in the context of that ignorance, the issues around understanding how climate is changing now and has changed in the recent past, and how people have adapted to those changes and are continuing to adapt, would I would suggest be absolutely central to some of the challenges that we should be looking at, and that there's a real risk in suggesting that climate change is just an issue for the future.
Yes, I mean, I'd certainly use the wrong term if in terms of the words, but I'm going to stick by what I actually meant by that. The question is, when is it the point at which climate change becomes such a big driver of where we are at the moment that you have to factor it into policy? And for the majority of climate change, I don't think anyone doubts that climate is changing now, and that some of that change is driven by the warming effects we're talking about, but not all of it. The climate has always changed and will always change, and that's the history of climate. What I do think, though, is that what a lot of people really are talking about is climate change big enough to actually counteract the effects of all the other factors that are in the policy mix. And in that situation, I don't think that climate change, as normally understood, i.e. driven by anthropogenic global warming, has probably had a massive effect so far. That's what most people, I think, have looked at this would agree in Africa, compared to all the other factors. And I illustrated this in malaria. There is no doubt that the models would suggest it probably has had a slight increase in malaria over the last 15 years, but the impact of human activity in other ways is so much greater than that. The actual impact of climate change on this has been actually non-measurable for practical purposes. It's slightly increased Highland malaria, but that's probably the only thing you measure. And I could repeat the same over several things. So you're right, I use my words clumsily, but the general point, which is what most people mean by climate change affecting humans, is actually big enough to have a signal you can pick up. I remain to be convinced that in Africa that is currently a situation. I'm happy for people to contradict that. There are many great experts in the audience here today.
Hello, hi. Can you hear me? Yeah, okay. I'm Emily Boyd from Reading University. Thank you very much for a very fascinating talk. I just have a quick question about the social science point that you made. And I just wondered from a policy point of view whether you could comment on how you see the best avenues for social science to actually contribute to enhance our understanding of resilience.
Well, I mean, let me preface this by saying that the great failure in the majority of areas of development in Africa, leaving aside climate change, is that we have the tools and they're not delivered, they're not used. The interaction between the person and what we can do fails at the last mile, to use the term of art from my own trade. That is the province primarily of social sciences, or the social sciences go well beyond that. I think that clearly as we develop more tools, first area where the social science can help us is to work out how people can use those. Will they use them? We may well produce things that people are simply not prepared to use, and that has happened repeatedly in history. Let me take as an example cooking stoves. I'm just going to take that as an example. I could choose one of many other ones. Everyone agrees that it would be much better if there were much better cooking stoves in Africa, and for climate change reasons as well as many other reasons, environmental reasons, a whole series of reasons, that would be a good thing. Lots of people have developed these over many years, and yet if you look across Africa, there are large numbers of not used, very well-designed cooking stoves, and traditional ones are still being used with charcoal and so on. Why is that? And I think these kinds of questions about how things are going to be used, if I was going to choose, that would be my biggest priority. There are many others, political, a whole variety of ones, that in a sense every one of the points I raised has got social dimensions to them. But if I was going to choose one, I think that would be probably my one. But my caveat again to that is not all of the skill for this comes from the classical social sciences. If I want to change behaviour, maybe I should be going to the Coca-Cola company marketing department as well as the sociology department of Sussex. Thank you.
I'm Guy Poulter from the Natural Resources Institute. I'm interested in your predictions and climate change on agriculture in Africa. And I think you said that we have to assume that by 2040, the agriculture in Africa will be very different. And I think the context of that was more in terms of the crops, the pluses and minuses that you showed. You also showed the pastoralists and the combine harvesters. The majority of agriculture in Africa currently is smallholder farmers. I wonder whether there was any evidence on, or any suggestions of how that would change, and whether when we get to the change of crops possibly in 2040, 2050, it's still going to be predominantly smallholder farmers or more to the combine harvesters.
The honest answer is we just don't know. But I think my caveat to that would be there have been countries that have moved increasingly away from smallholder farming as the main source of their staples, and then move back again, like Zimbabwe, and it's tended to follow socioeconomic development. So the probability is that as the socioeconomic development in Africa, at least the contribution of smallholding farmers to the overall amount of food will decrease. That's the probability. But population increase means there may well still be a lot of smallholder farmers. And the answer is actually it's likely to be very variable across the continent, and within any country it's probably going to be variable again. But unless there's someone, there may be people in the audience who could answer your question with a better prediction than my answer is, I don't think we know. But that would be my suggestion about where the direction of travel is likely to be.
Alan Thorpe from the European Weather Centre. I wanted to ask you a question about capacity building. One of the issues for predicting extreme events and up to seasonal is actually the lack of measurements in Africa at the moment to initialize those sort of forecasts. And one of the issues there is scientific capacity building to enable a proper meteorological network that can actually tell us what's actually going on. And forecasts may follow in terms of their ability to predict even out to the seasonal timescale. Up to now, it's been a really bad story in terms of this, and I just wonder what your perspective was in terms of the next 10 to 20 years.
Right. Well, capacity strengthening in Africa and in resource-poor settings in general, and education, is one of the most fraught areas there is. Everyone agrees it's a good thing. Everyone agrees that it is a good thing, but their discipline in particular is the most important priority at this moment in time, given limited resources. And if I had a microbiologist, I'm sure I'd have had the same question on a microbiological talk, saying, "Isn't it tragic that there aren't more microbiologists?" And it'd been fair. I think there are certain points of commonality on this. The first is the institution. We must build up the base of people who can do science in general in Africa. And that includes better secondary education, improves strengthening institutions and the individuals across a whole range of disciplines in universities in Africa, and there are a number of other areas. My own department is probably not the best place to do some of these, but it can do some others. Where you choose and whether you then choose to say, actually, the area we need most of is this.
Are you optimistic?
Yeah, I'm completely optimistic about that. So if I look at the Africa of now compared to the Africa of my childhood, the number of excellent African scientists is infinitesimally greater, and there are now universities in virtually every country I know, which was not the case even 10 years ago, which are serious universities, teaching well, certainly to master's level, and often collaborating. I mean, the trend is definitely good, but it's very patchy. Not every country has got the same depth, and within any country, there is some disciplines that are actually very badly served compared to others. And also, you can often end up with isolated islands of excellence, but nothing around it which actually would make it useful for policy. So you have a group of fantastic microbiologists, but no one who's any good at clinical medicine, or that kind of thing. You need to actually, from a policy point of view, you need to think about the whole sweep. So it is very difficult to have arguments that are rational about giving priority to one area rather than another. But the general principle that the whole water level needs to go up, absolutely everyone can agree on, and it's going to be central to Africa's development efforts. But Africa itself, all African governments would say this is a priority for them. The real difficulty for us actually is not agreeing on that, which we all do agree on, but what bits of capacity strengthening work. There are many very successful examples of capacity strengthening. We know that because there are people who are excellent in good institutions. There are also many that are absolutely rubbish. And the problem is we have not systematically looked at how the good ones were good and the bad ones are bad, because the time frames are so long. And until we do that, it's quite difficult to work out a clear path to this. I mean, this is a very vexed question. I could go on about this for at least an hour, but I'll stop at that point. I think I've got time for one more question.
Yeah, Phil Cottle, Forestry. We model natural hazard risk in forestry around the world. And in Africa, in South Africa, I've noticed in the last 20 years a 3 times increase in the rate of loss. And when I read the papers, that is predicted to grow. So I think my question is, relating to Alan's question of capacity building, is I feel what we need is possibly a stronger link. Now I'm embarrassed. A stronger link between science policymakers and, shall we say, African universities and centres of excellence to turn that general data, and it's a fascinating talk, but it's very, very general. To me, if you like, it's a bit useless. But I don't mean that in a rude way, in a constructive way, in the sense that if you're going to invest in foods and forests and things like this, you need to know about linkage with rainfall, temperatures, soil, on a county scale or a valley scale, or a landscape scale, shall we say. And this is somewhere where I feel the universities are sort of letting us down, because as a corporation, as a company of people growing anything, if we're going to cover these risks off in the international markets, we've got to be able to model it. And you can't model it on general data because your models go wrong. So just to sum up, do you see that link existing, or do you see it forming where policy research can actually look on the ground at variabilities on a local farmer plantation scale?
Well, I agree with 3 things. First time it's ever said to me, my talk's useless to my face. I'm sure they thought it regularly before, but I think I actually agree with three of the 3 things you've said. But it's difficult to formulate a clear response to that. The first one is we clearly need to have better data in Africa across a whole range of stuff. Part of the problem for people who are doing modelling at the moment is technical and computers and models and various other things, but a lot of it's to do with the fact there are so few places from which we have reliable data going over long enough that actually you can say anything useful. And that's both for the macro models and for the micro models. In fact, there's virtually, apart from a few of the things like the tea plantations, which have kept meticulous records over maybe 100 years, which are useful for their very local things, data is very thin on the ground. Now, everyone agrees that getting those kinds of data are useful, and the data needs, and this I could repeat this in virtually every area of development, the data needs in Africa are huge. There, in a sense, I revert back to my previous thing. We clearly need to improve the ability, the statistical ability, the biological sciences, the physical sciences. There's a whole series of skills we need. Which ones we choose to prioritize is, in a sense, sort of political decision. Because the moment the lack is so universal that we're nowhere near that, whether I was trying to model floodplains, or if I was trying to model malaria incidents, or model traffic density, all of the same. All of those arguments could be made in Africa, and they'd always be right. So I agree with you completely, but actually we are going to have to move, at a pace which is manageable. And what it's very dangerous to do, in my view, is to prioritise this enthusiasm or that enthusiasm, because what ends up happening is, I've seen this so many times. Someone tugs a minister's. Not a minister's sleeve, but someone like my sleeve, and they say what you really need is X. So X is produced, and the next person comes along, and X stops, and Y starts. And actually what you need is a general increase in absolutely everything, plus some centres of excellence. But I couldn't agree more in principle.
Okay, right, thanks. So I better draw to a close there. Thanks for a really interesting discussion. There's lots of different perspectives have appeared, which has been really quite revealing. Lots of challenges, but I think lots of opportunities over the next few years. So thanks again, Chris. Thank you.